Today, we're going to start talking about, well, we're not going to start. We are still going to talk about section 6.5. The remainder and factor theorem, really what we're doing is still long division. Okay? The remainder theorem says if a polynomial is divided by x minus k, then the remainder is that polynomial evaluated at k. The key to this whole thing is that it has the form x minus some number k. The k will be filled with some number. So you may see like x minus 3, whereas 3 would be that k value. Does that mean I could never see something like x plus 3?
Yes.
So, exactly right. We could have something like x minus a negative 3 that has been simplified. Okay? So, yes, plus a positive is the same thing as plus. Okay? So, we can have both of those. So the number that you're working with, that k value, is going to have the opposite sign of what you see. You're working with a positive 3 when you have a plus. You're working with, or when you see minus, you're working with a negative 3 when you see a plus. So we're going to divide x cubed plus 2x squared minus 6 minus 9 by x minus 2. Okay. I am going to show you what is called synthetic division. Okay? Synthetic substitution. It is exactly like synthetic substitution. So, what k value am I working with when I look at x minus 2?
2.
We're looking at a positive 2. So, your k value is what's going to go in the corner. So we're going to have 2 up in the corner. And do I have every power of x? I've got x cubed, x squared, x, and then a constant term. So I'm going to put those coefficients. What's the coefficient for x cubed? 1. What's the coefficient for x squared? 2. Negative 6. And negative 9. Put the line down below, and we're doing the same process that we did before. Drop our 1 down, switch colors here. Drop 1 down, okay? Then we're going to multiply 2 by 1, 2, add down, 4, multiply by 2, get 8, add negative 6 to 8 to get 2. And I end up with a 4 and a negative 5. Okay? Put your ending box in.
Wow.
So that means if I were to evaluate this coefficient at negative 5, or at 2, I would end up with negative 5. Here's where that remainder theorem comes in to effect. We actually just divided this. Instead of doing the long division, if it is in this specific form, x minus some number, it cannot be in any other form. So you can have x minus or x plus like we talked about on the first slide. If it's in anything else, you can't do it. So that's why I have to show you long division. Here's where I'm going to surprise you guys. This last number right before your box, the 2, this is your constant term. Okay? This next number is your x term. This number, this 1, is going to be your x squared. So, if you were to go through the long division process, you would end up with x squared plus 4x plus 2, and our remainder would be minus 5 over x minus 2. The key to this is work backwards. The stuff in blue would be your answer. Yes. X minus 2. Enough bird calls. So that's what we divided by. Yep. Yep. Then it would be 2x squared. Yep, those are your coefficients for the polynomial that you get when you divide. Good. Any other questions on that? All right. Now we're going to divide x cubed plus 2x squared minus 6x minus 9 by x plus 3. First of all, am I in the form that I can use synthetic division?
Yes.
Yes? How do you know?
Because x plus 3 is.
We have x plus 3. That's a form that we can use. What is the k value that I'm going to use? K value is -3. So what's going in my box? -3. -3 because since I see a plus, that 3 has got to be negative. So it's really like x minus -3. Yep, just like we did in the last slide. We had x minus 2. We put a positive 2 up in the corner. Okay? Line up our coefficients. X cubed, 1, x squared, 2, -6. Same polynomial that we're dividing by a different number. All right. So why don't you guys work this, and we'll give this a try. Okay, so you guys talk me through this. What are we going to do? We're going to drop the 1. Multiply that by -3. So add down, I get -1. -3 times -1. +3. -3 by -3 is +9. -9 plus 9 is going to leave me with 0. Okay? So, again, this is our remainder. That's our remainder. Okay? This is our constant. This is our coefficient in front of x. This is our coefficient in front of x squared. So the polynomial we get is going to be x squared minus x minus 3. Since I have a remainder of 0, you don't have to do anything with it. That means it divided out evenly. Guys. Okay? So this is all we're going to end up with here. Questions on that? Okay, so the next thing we want to talk about, the factor theorem, says that a polynomial has a factor of x minus k. Notice, same form we were just working with. So it'll be x minus some number or x plus some number. If and only if, when you evaluate the function at k, whatever that number is, it equals 0. So when you do your synthetic division, that remainder will be 0, just like it did in the last problem.
When we get to
Okay. Now instead of asking you to divide, we're going to ask you to factor 2x cubed plus 11x squared plus 18x plus 9, given that f evaluated at -3 is 0. Okay? So this isn't exactly in the same format that we were just working with, but what we know is that if we have f evaluated at -3 equals 0, that means we have x minus -3. So our k value is going to be what? -3 is our k value, okay? And you can get that right from inside those parentheses. So now it's going to look just like what you want. So now that we know what our k value is, we're going to put -3 inside the box. And we have 2x cubed, so the 2 goes up. Do I have an x squared? What is it? 11. X, 18, and a constant of 9. So we're going to move our 2 down. 2 times -3 is going to give me that -6. Add, I'm going to get a 5. 5 times -3 gives me a -15. 18 plus 15 is going to give me a +3. And I end up with -9. Add that, and I get 0, which is exactly what we should expect. In section 2.2, or not 2.2, 6.2, I showed you synthetic substitution, meaning that when you plug this in, this was what that function is evaluated at. They tell us that the function is evaluated, or tells you that when we plug in a -3, we should get 0 out as our answer. So this means that we end up with 2x squared plus 5x plus 3. And this is something that we can factor. Goes back to chapter 5, goes back to your factoring from Algebra 1. Now we should be able to plug in with our 2 sets of parentheses. Okay, so we factored out x plus 3. Okay, since we have x minus that -3. Since this is 0, x plus 3 has to be a factor. So that's going to tag along with us. So we're going to have x plus 3, and then we're going to set up our next 2 sets of parentheses. And now we can go through our guess and check. If you use the AC method, that's fine. Slide, divide, bottoms up, if you guys know that one. Otherwise, I'm going to ask myself, What do I multiply together to get 2x squared? 2x and x. What are my signs going to be? Same. How do you know? Looked at this plus 3. Since it's positive, we know they're the same. We look ahead to get both positive. And what am I going to multiply together to get 3? 1 and 3. Okay? The question is, do I want my 1 to go with this 2x here, or do I want my 1 to go with the x? 1 to go with the x? Okay? So, we got to double check ourselves to make sure we got this right. Okay? 2x times 1 is going to give me what? 2x. 3x times x is going to give me 3x. 3 plus 5, or 3 plus 2 gives me 5x, which is exactly what we want. Which means this whole thing will factor down into x plus 3 times 2x plus 3 times x plus 1. And that is the answer. Any questions on that? All right.